Welcome to the deep dive. Imagine this scenario for a second. You're working on a massive, highly important project,
Oh, we've all been there.
right? And you need access to a cutting-edge AI model, something like GPT-5 or maybe Gemini 2.5 Pro.
The really expensive stuff.
Exactly. But there's a catch. Maybe it's way too expensive for your current budget. Or maybe you're operating in a region where access to that specific official API is completely blocked.
Which happens a lot more often than people think.
It really does. So you do a quick search, and you find a cheap third-party service. And they promise you the exact same model, the exact same performance, for a fraction of the cost, with absolutely no geographical restrictions.
Sounds like an absolute steal rate.
You plug it in, it starts generating text, and you think you've just solved your problem. But what if you aren't actually getting that state-of-the-art model at all? What if you're really just getting a cheap, open-source model wearing a fake mustache?
It's a terrifying thought if your work relies on that data. And it's exactly what we're going to explore today.
Yeah, we are looking at a really fascinating research paper today.
Right. It was published in December 2025 by researchers at the CISP Helmholtz Center for Information Security. The paper is titled Real Money Fake Models, Deceptive Model Claims in Shadow APIs.
Such a great title.
It is. Our mission for this deep dive into the source material is to completely pull back the curtain on these so-called shadow APIs. We're going to uncover the deceptive bait-and-switch tactics they use, and we'll explore the massive silent reproducibility crisis they're causing across the entire scientific community.
The researchers actually included a hilarious comic in the paper to illustrate this. It shows an assembly line in a shadow API factory.
I love that visual.
Yeah, you've got these little capybaras rolling down a conveyor belt, and they're being dressed up in shiny, futuristic OpenAI armor.
Just totally disguised.
Exactly. Then a shady salesman hands these capybaras in robot suits over to a long line of eager buyers. The buyers take them back to their research labs, put them to work, and suddenly realize this highly advanced robot is just a rodent in a metal suit. Okay, let's unpack this. What exactly is the access problem that leads a smart developer or researcher to buy the capybara in the first place?
The capybara analogy is great because it perfectly highlights the information asymmetry happening here. To understand why these shadow APIs even exist, we really have to look at the access barriers surrounding frontier models.
Because it's not just about wanting a discount.
No, exactly. The official APIs provided by the major AI labs are generally priced for enterprise customers. If you're an individual researcher, a student, or like a bootstrap startup, those API bills become unsustainable incredibly fast.
Right, it adds up quick.
But beyond the financial cost, there are strict geographical restrictions. For various legal, security, and export control reasons, official providers block direct API access from several regions. For instance, the official OpenAI API can't be accessed directly from countries like China, Russia, or Iran.
Right, but global AI research doesn't just stop at those borders. Major AI conferences are filled with groundbreaking submissions from researchers in those exact regions. So out of sheer necessity, this massive third-party market emerged.
Which brings us to the core definition of today's topic.
Shadow APIs. These are third-party platforms that claim to provide you with the exact same output as the official models, but they do it via indirect access. They bypass the region locks, they drastically cut the costs, and they act as a middleman.
And from your perspective as a user, the surface-level experience looks identical. You send a prompt, you get a response. But from a supply chain perspective, these shadow APIs are complete black boxes.
Total mystery.
When the researchers audited this ecosystem, they found an absolute wild west of infrastructure. They identified 17 prominent shadow APIs. Out of those 17, a staggering 15 are run by completely anonymous individuals.
We have 15 out of 17.
Yeah. There's no corporate entity, no legal accountability, nothing. Users are literally paying for these services via personal peer-to-peer payment apps like WeChat or Alipay.
That is wild to me. You're doing high-level, grant-funded AI research, and you're sending your computing budget to a random guy's WeChat account.
Exactly. The paper noted that only one of the 17 providers actually had a legitimate corporate registration, which in China is an ICP filing.
And technically, the infrastructure behind these services is mostly open source, right?
Yes. 11 of these shadow APIs were built using open-source AI redistribution tools, things like a system called One API or its derivative New API.
That's a crucial detail. Those tools were originally designed for innocent self-hosting, basically to unify different APIs into one manageable format for internal use.
But here they're being weaponized to route, intercept, and potentially manipulate your requests across multiple unauthorized nodes.
But couldn't you argue that these middlemen, despite being sketchy, are just democratizing access to AI? If they're providing a workaround for people who are priced out or geo-blocked, maybe the end justifies the means.
You could certainly make that argument if they were actually providing what they promised. But the paper shows they aren't democratizing frontier models, they're monetizing deception. And the scale of this illusion is what makes it a crisis.
Definitely not just a niche hobbyist problem.
Not at all. By December 2025, the researchers found that the single most popular shadow API in their study had accumulated over 58,000 GitHub stars.
58,639 stars to be exact. That's massive enterprise-level adoption.
It really is. And more alarmingly, the endpoints from these shadow APIs were utilized in 187 peer-reviewed academic papers.
Wow.
We're talking about papers accepted at the absolute top-tier venues for artificial intelligence, conferences like ACL, CVPR, and ICLR. Together, those 187 papers had already racked up nearly 6,000 citations.
I want you, the listener, to just imagine that for a second. Imagine you're reading a groundbreaking, highly cited scientific paper that introduces a new medical diagnostic tool or maybe a new legal reasoning framework. You are completely unaware that the AI data that entire paper relies on wasn't generated by the state-of-the-art model they claim to use.
It was laundered.
Exactly. It was laundered through an anonymous, unverified server. You might be thinking, well, who cares if it's an unofficial channel as long as the output is good? But the data shows us something terrifying. The output is terrible.
Users treat these shadow APIs as interchangeable substitutes. They assume the only difference is the routing. But when the researchers conducted a multidimensional audit across scientific, math, medical, and legal benchmarks, the performance just fell off a cliff.
What kind of numbers are we talking about here?
Let's look at the medical field, which they tested using the MedQA benchmark. This is essentially the U.S. medical licensing examination. With the official API, the Gemini 2.5 Flash model achieved an accuracy of 83.82%.
Which is pretty solid.
Right. But when they tested the exact same model claim through the shadow APIs, the accuracy plummeted to roughly 37%.
We had a drop from almost 84% to 37% on a medical exam. That isn't just a slight degradation. That's worse than random guessing on some multiple choice questions.
It's a complete collapse.
But hold on, if these providers are secretly substituting the official models with open source alternatives, aren't some of those open source models actually pretty capable now? Why is the performance falling off such a steep cliff?
It's because the shadow providers aren't substituting your prompt with the best, most capable open source models available. They're substituting it with whatever runs the absolute cheapest on their backend.
Just to maximize the profit margin.
Exactly. They aren't optimizing for your accuracy, they're optimizing for their server costs.
That makes total sense. And the real-world stakes of that become incredibly clear in the paper's examples. There was a medical question about perinatal HIV screening during labor.
Oh, yeah, that was a striking example.
The official API correctly identified the protocol, stating the need for an antibody differentiation immunoassay. It gave the right, highly specific medical procedure. But the shadow APIs, they confidently spat out the completely wrong answer, claiming the test determines the genotype of the virus.
Which is a fundamental misunderstanding of the diagnostic protocol. Mixing up an immunoassay with a genotype test in a clinical setting is a catastrophic error, and we see the same collapse in the legal domain.
Right. They tested the models on legal bench.
Yes, specifically looking at a precedent regarding juror honesty known as Rule 606B. The official API easily parsed the precedent and correctly applied the rule regarding when testimony is barred. The shadow APIs completely confused the basic standard of admissibility with the standard for a new trial.
Or they just cited completely unrelated rules.
Exactly.
If a lawyer or a legal researcher relied on that shadow output to prep a brief prolissword, they'd be building a case on complete legal fiction. But it isn't just about getting the wrong answer. It's about the illusion of safety. You might be using a specific model because it has robust built-in guardrails against generating harmful content. But if you're using a shadow API, those guardrails might be entirely missing.
What's fascinating here is how wildly unpredictable the safety behaviors become when these shadow APIs face malicious prompts. The researchers use standard safety benchmarks like Jailbreak Bench and AdV Bench to test how the models handle adversarial attacks.
Like the Base 64 attack.
Right. A base-64 attack is essentially taking a harmful prompt and translating it into a string of random-looking letters and numbers to bypass safety filters. Under a base-64 attack, a shadow version of GPT-5 Mini yielded a harmfulness score that was double the score of the official API.
Double.
Yeah, 0.04 versus the official 0.02.
So it was twice as likely to generate the harmful content because the cheap substitute model didn't have the sophisticated filtering to recognize the encoded text.
Right, but it goes the other way too, which is almost more dangerous for developers.
Mm.
Against a different type of attack called a flip attack, which is another obfuscation technique, the shadow versions of Gemini 2.5 Flash heavily underestimated the risk.
Meaning they scored much safer than the official baseline.
Yes, the official API recognized the attack and flagged it with a high harmfulness score of 0.90. But the shadow APIs gave it a much lower score of around 0.67.
That's a huge problem. If you're an engineer building an enterprise application and you're using a shadow API to stress test your safety filters, you're getting completely distorted feedback. You might deploy your app thinking your system is secure when it's actually highly vulnerable.
It proves you absolutely cannot rely on shadow APIs to test AI safety guardrails. The false negatives give you a completely unearned sense of security.
So we know the performance is terrible and the safety is unpredictable. But if the models look the same on the surface, how on earth did the researchers actually catch them? Is there a way to definitively prove a model is wearing a fake mustache?
This brings us to the detective work. They used an interrogation technique called LLM map.
LLM map, how does that work?
LLM map is essentially an active fingerprinting tool. Just like human beings have distinct linguistic quirks or a specific way of structuring sentences, these models have unique statistical signatures. LLM map asks the models a curated set of highly specific questions. It then takes the responses and measures what's called the cosine distance against a reference database of known official models.
So it's mapping the linguistic geometry.
Exactly. Think of cosine distance as a mathematical way of measuring the gap between two texts. It answers the question, how closely does this text match the known fingerprint of the model it claims to be?
And the results of this fingerprinting are the smoking gun of this entire deep dive. Across the 24 shadow endpoints, they evaluated an alarming 45.83% completely failed the fingerprint verification.
They're entirely different models.
On top of that, another 12.5% showed huge deviations in their cosine distance, meaning they were severely degraded or altered.
The actual switcheroos they uncovered make the deception glaringly obvious. Users who thought they were paying for the frontier capabilities of GPT-5 were in reality having their requests quietly routed to GLM49B.
Which is a much smaller, cheaper model.
Much cheaper.
It gets even worse when you look at specialized models. DeepSeek Reasoner is a model specifically designed with an advanced thinking mode for complex, multi-step logic.
Oh.
But when researchers requested DeepSeek Reasoner through the shadow APIs, the fingerprinting proved they were just being served the basic, non-thinking DeepSeek chat model.
You're asking for a mathematician and getting a conversationalist.
Perfectly put.
To ensure their fingerprinting wasn't just a fluke, the researchers brought in a secondary independent statistical method called model equality testing, or MET.
MET? What did that show?
MET looks at the broader output distributions over hundreds of queries. It corroborated the LLM map findings completely. It statistically proved that the outputs from the shadow APIs were drawn from entirely different distributions than the official models. Furthermore, when they analyzed the meta-information, the shadow APIs exhibited wild, irregular spikes in latency and token counts.
Let's pause on that token count spike because that's a huge red flag.
Yeah.
Why would the token count spike if they're just swapping the model?
If you're using a shadow provider, they're routing your prompt through a fragmented network of cheap backend servers. To do that, they often have to re-tokenize your prompt or inject hidden system instructions to force the cheaper model to act like the expensive one you asked for.
Oh, I see.
That invisible overhead artificially inflates the token count, which the user, end up paying for. The heartbeat of the model becomes highly unstable.
Here's where it gets really interesting. Why are the shadow providers going through all this trouble? It all comes down to economic scams. The paper breaks down 3 distinct ways these providers are actively scamming users. Scam number 1 is the information premium.
Right, the markup scam.
Exactly. This is where they charge a massive premium, like a 7x markup for an older model, like Gemini 2.0 Flash.
Yeah.
But the fingerprinting shows they're secretly serving the newer, differently priced Gemini 2.5 Flash behind the scenes to pocket the margin. They're manipulating the pricing tiers based on user ignorance.
Scam number 2 is discount substitution. Here, they charge you the exact official rate for a premium model like GPT-5, so the pricing looks totally legitimate on your invoice. But then they silently substitute it with a cheap model like GLM-4. They pocket the entire difference between the premium price you paid and the near zero cost of running the cheap model.
And scam number 3 is the resale markup. They add a modest surcharge, say 9% over the official rate, acting like a premium proxy service that's doing you a favor by bypassing region locks. But even with that surcharge, they still substitute the back-end model to maximize their profit margins. It's value destruction on a massive scale.
The researchers actually broke down the math on this value destruction. They ran a test of 12,273 queries that were billed at the official GPT-5 rate, which cost them $14.84. But when they measured the actual token volume and capability delivered by the Shadow API, it was only worth $5.70.
Wow.
You're paying full price for less than 40% of the actual value. The provider pockets that massive margin, and you're left with degraded, faulty data.
If we connect this to the bigger picture, the financial scam is obviously terrible for the user's wallet, but the cost to the scientific community is catastrophic. Let's go back to those 187 academic papers that cited these shadow APIs. Conservatively, let's assume that just 30% of those papers, about 56 studies, need to be rerun because they unknowingly base their methodology on fake models.
It's a logistical nightmare.
Between the direct API fees and the cost of researcher time to redo the work you're looking at, up to $140,000 in wasted resources.
And that's just the direct cost for those specific authors. What about the 5,966 other papers that cited them?
The ripple effect.
That's the real silent corruption of science. If paper A uses a shadow API that hallucinates a medical finding, and paper B, C, and D build their hypotheses on paper A, you've built an entire house of cards on a foundation of laundered AI data, and there's no visible error signal for the researchers reading it. The data just looks like data.
So what does this all mean? How do you, the listener, protect yourself, your research, or your company from this ecosystem? The researchers lay out a very concrete action plan. Rule number 1 is the simplest. Never use shadow APIs for research workflows or production apps. Period. You must use official APIs directly.
But the researchers understand that in some highly restricted contexts, an auditor or a security team might need to verify a third-party endpoint. If you absolutely must use one, they recommend a strict 4-stage auditor protocol. First, you run LLM map probes. If the cosine distance of the responses is greater than 1.2 times the official baseline, you flag it immediately as a fake.
And if it passes that first check?
Second, you run the MET statistical test on a minimum of 500 samples to check for distributional equality. You need a large sample size to catch the anomalies. Third, you check for wild latency variance across at least 3 independent sessions. If the response times are jittery, it means your requests are being bounced around a sketchy network. And fourth, you demand proof of a corporate legal entity, like an official ICP registration. If the provider is just an individual taking WeChat payments, walk away.
Whether you're a student writing a thesis, a developer building an enterprise app, or an executive prepping for a major tech strategy meeting, you have to realize that treating unverified third-party APIs as interchangeable with official models is a massive operational liability.
You're essentially handing over your customer data or your proprietary research to an anonymous entity and getting garbage data in return.
You can't assume the label on the box matches what's inside.
This deep dive has taken us from the somewhat humorous image of capybaras in robot suits to the grim reality of medical exam accuracy dropping from roughly 84% to 37%, a staggering 47-point drop, and finally to the blatant economic bait-and-switch that's quietly undermining scientific reproducibility worldwide.
It really changes how you look at the entire AI ecosystem. You think you're accessing the absolute pinnacle of human computing, and you might just be lining the pockets of a scammer running a server out of their basement.
This raises an important question, something for you to think about long after this discussion ends. We've talked about the immediate damage to academic papers and user wallets, but consider the long-term integration of AI into our daily lives. If thousands of cutting-edge scientific papers and commercial AI applications are being built right now on a foundation of silently substituted downgraded shadow models, how long will it take before these invisible hallucinations, these fake facts generated by fake models, become permanently hard-coded into the technologies, medical protocols, and legal frameworks we rely on every single day?
That's a chilling thought to leave on. The infrastructure of our future might literally be built on digital capybaras. Thank you for joining us for this deep dive into the source material. We'll catch you next time.